Welcome to the Stellar Cyber Security Operations Platform. Stellar Cyber is an open XDR platform, open in the sense that it is open to all data sources. We have hundreds of integrations and support any data source, whether pushed to us in the form of syslog or fetched by the means of API calls. We enrich every record coming into the platform with geolocation and threat intel. We have hundreds of out-of-the-box detections using our ML modeling or our rule-based analytics engine. Netskope is a premier partner of ours. The Netskope Secure Web Gateway is a preferred feed of Stellar Cyber. We ingest raw SWG records and honor the alerts that are derived. Objects such as user and device are extracted and used for correlation with many other data sources within the platform. Here you see an example of some of the data points that we extract, such as usernames, host names, URLs, and threat names, as well as the categories and alert types that are derived from Netskope. All these are used for correlation within our platform. Netskope data is further used for our ITDR area of our platform, where users and hosts and other applications are extracted for tracking within our identity, threat, and detection and response. Our latest Netskope integration is the form of Netskope's CloudTap service. CloudTap provides native packet capture of user network session data. Stellar Cyber accepts the CloudTap captures as a stream and further enriches the streams with Netskope user. The user information is then used for our ITDR, identity threat detection and response capabilities within the product and used to build additional context. Let me demonstrate the effectiveness of this by showing you a real-world example. First, let me explain how CloudTap works. CloudTap is a service provided by Netskope. It works by capturing network session as PCAP and coupling the network session with the users that are generating those sessions. That information is written up to an AWS S3 bucket. Netskope then provides a Docker container that they call a stitcher to progressively read the PCAP and user information and transport it as a stream using the Geneve tunneling protocol. User information is embedded in the stream within the Geneve header. Stellar Cyber, upon receiving the stream, will convert the network stream data into what we call interflow, which is network metadata. We also extract the user information from the stream and enrich the metadata with the user information. The network stream is enriched, subjected to our out-of-the-box NDR detections, along with Stellar IDS for malware detection. Here we have a case that was derived by Netskope CloudTap data, along with Stellar Cyber's layered approach to AI, specifically GraphML. GraphML finds relationships between objects that are contained within records, and when relationships are discovered, builds them into collections that we call cases. This case uses two separate Netskope records where malware and other malicious activity was detected. We have this first one, the emerging threat, and this external Trojan, both of which came from Netskope CloudTap. The system then correlates that Netskope activity and user information with other lateral movement attempts that were derived from non-Netskope data sources, such as raw Windows events coming off of Windows systems. Let's take a look at the analysis of this case. Here we see the objects that have been extracted from all the records in this collection. Of primary interest is our log user at stellarcyber.ai user. That user is the one that was identified by means of the Netskope CloudTap. We have an internal system, the 10.36.282, which looks like it was then used to access a system outside of our environment, this 195.66.214 system. Well, what was done? If we simply look, we'll notice that the activity between these two was an emerging threat, which, when analyzed, says that this traffic has an emerging threat based on ransomware. And then an external Trojan. Both of these were network traffic that was obtained using the CloudTap. All the other records were obtained using Windows records, Windows logs off of these local systems. And then we were able to identify these users from these local systems and couple that or correlate that with the users on the Netskope activity and the Netskope network traffic. incredibly valuable and enriched information that puts this activity into context, and we can clearly see what to do next. If we move back to our detection, we'll notice that AI has been used to summarize the case. In fact, it tells us, as an overview, that a brute force attack was aimed at compromising accounts starting from here and making lateral movement using the log user account, which was correlated between Netskope and internal Windows systems. Key insights were provided, the impact of this attack was given to us, and recommended next steps such as investigating and blocking that internal asset and reviewing the authentication processes of the log user account. Thank you for the opportunity to demonstrate the capabilities of the Stellar Cybersecurity Operations Platform. By integrating with Netskope's secure web gateway and CloudTap services, we can provide a truly unified and elevated security experience.